All right, we're going to get started. We're running a couple minutes late, but we're going to roll. We're talking about Atrium Enterprise, which is an ODL distribution designed to support, specific, well-defined use cases. We're kind of at work building our first one, and we're going to talk about that. So you've probably seen this slide in some of the other presentations here today, but the basic requirement here from Microsoft IT is to try to reduce their MPLS and sort of carrier-provided WAN costs by having smaller dedicated WAN pipes and offloading things to the internet instead. They talked about sort of the Internet First initiative, where by default things will go to the internet, and only the things that need special treatment will use the expensive corporate network. And so we're building a solution to help them solve that problem in cooperation with some of the ONF members and the Microsoft IT team. So Atrium Enterprise is a distribution of OpenDaylight that's been tested, integrated, tuned for specific use cases, and sort of recognizing that upstream OpenDaylight isn't very consumable for most people, and a lot of people don't want to do super custom things and become deep software developers in order to use it. So the thought is that we'll take the basic distribution, add support for specific use cases, test it with specific pieces of hardware, and certify at some level that this is something that you can take and deploy. And in working with Microsoft as sort of the first partner in this, our goal is to build something that's good enough to meet their needs to the point where they're going to want to deploy it. And in some ways, we're sort of a midstream project. We have some software artifacts, but the bulk of the thing we build comes from upstream, which is OpenDaylight in this case, and we'll talk about that in a little more detail. So the first use case is this unified communications use case, real-time audio, video, and other kinds of things. There's a specification from the IMTC, which is a standards organization of sort of multimedia, telecommunications, and universal communications providers. And so one of the things we're trying to do is support the specifications they've created for how to integrate SDN with universal communications. The other thing is to adapt it to the ONF's common intent northbound interface. We've been working in ONF to design a single northbound interface that could be put on all kinds of infrastructure controllers and provide sort of a consistent interface, and I'll talk about that a little more. So that, this is a nice use case because there's just a very simple cost-based ROI. If they can go across all of their many branches across the world and reduce the WAN costs in each of them, it turns out to be pretty substantial. So the why are we doing this SDN thing is really easy to answer and well-defined and helps us get there. And we have a real live customer that really has this pain point. It's not a bunch of vendors and theorists talking about what might be. So essentially what happens is you end up with two different interfaces that could connect a particular branch with another branch. The high quality and very expensive corporate WAN and the less predictable and much less expensive internet. And the trick is to try to find a way, without replacing their entire infrastructure and doing massive changes, is to find a way to sort of insert some intelligence into the network so that when something's going to leave a branch office and go over one of these two networks, the time-sensitive things end up using the corporate WAN, and the rest of it sort of by default goes to the internet. So there's somewhere between kind of this X, where the access begins in the branch on top, and Y, where the sort of the wide area demarc is at the edge of the building. Somewhere in there, we've got to do something to cause this traffic to take the right path, and then sort of the same thing when we get to the other side. And so what we've proposed initially is sort of a drop-in steering appliance that can transparently be inserted into their network. It doesn't matter what kind of edge routers they have connected to the WAN. It doesn't matter what kind of access routers they have within the branch. Ultimately, we're suggesting that this appliance could be dropped in between one of those boxes and the other and accomplish this steering in a way that wouldn't cause them to really change anything. They don't have to reconfigure existing stuff. They're really just dropping in kind of a bump on a wire. And because the data rates on these WAN interfaces are on the order of hundreds of megabits, not tens or hundreds of gigabits, it seems reasonable to think that a software-based forwarding plane would be able to keep up with this. I think, an x86 running any kind of a vSwitch can handle, a couple of gig these days without even breaking a sweat. And, if you throw lots of cores and acceleration things at it, people are doing upwards of 40 gig. So initially, at least, we're gonna try to do this just using software. And essentially, we would have some kind of an x86 box. It would be running an instance of the Open vSwitch that understands how to do the type of steering we need to do, and it would be running an instance of the OpenDaylight controller, probably both in the same box as virtual machines or containers or something, at least initially, and until we see really kind of high speed. Later on, we may move to a hardware-based solution or a different software solution or something, but this seemed like the quickest and easiest way to get something useful. And again, we could sort of steer the traffic out two different physical interfaces to split them between these two networks, or we could do some kind of a edge marking DSCP kind of a technology so that something downstream from us would be able to look at the markings and do the kind of steering. Either of those options are pretty easy. And so we talked about using the intent-based model to do this, and really the intent-based model, as opposed to kind of the traditional way that we operate networks, is based on describing the problem. I would claim that traditionally we've described the solution. You get on your CLI and you type things that cause a particular protocol to get configured in a particular way, and this really isn't about here's what my application's trying to do, it's about here's how the network ought to look. And so we're trying to move to a model where people and end users describe the problem and some smart piece of software figures out what the solution is. And so we're modeling the workload requirements instead of modeling the network. In the real world, kind of the classic way to understand this is, if you go to the Tylenol delivery man and you ask him for an aspirin, he's going to say he doesn't have any aspirin and you're going to go home with a headache. If you go to someone and tell them, make my headache stop, they might give you Tylenol or aspirin or a massage or a bottle. I mean, there's a million ways to deal with a headache. So if you tell the system exactly how to do it, it turns out you take away a lot of degrees of freedom and a lot of opportunities for optimization. If you tell the system what you want, you can have smart algorithms that understand the state of the whole world that actually kind of figure that out. And so in the universal communications use case, what it means to do this based on intent rather than on kind of the more traditional model is we basically are working with Skype call server, and every time it sets up a new audio or video session, it randomly assigns a TCP UDP port. It encrypts that stream so that no amount of kind of signature analysis or deep packet inspection really has any hope of figuring out what's going on inside of that. And that's really one of the big changes here, that the DPI model is sort of an advanced guessing model. You're not really sure what this is, but if you poke around it enough, you might make a pretty good guess. With the onset of encrypted everything, the ability to do that is going to completely go away, and we're going to need a different way of getting there. And so this model says the original source of truth, in this case the call server that's setting up the call, needs to talk to the SDN controller and tell it, I just set up a call, here's what it looks like, here's how you need to treat it. And so in the intent-based system, we essentially have two different groups that represent time-sensitive traffic. And when the call server sets up a new call, it pushes something into our label manager that's essentially a 5-tuple that allows you to identify and classify that traffic on the wire. And then it pushes a reference to that particular flow into one of these time-sensitive groups, and that's sort of how the controller knows it needs to go and push new rules into switches and change the configuration of the network. So last year in the ONF, we looked at many projects, talking between sort of things outside the SDN controller and the controller itself. And We wanted to find a common interface across all of these, but we also recognized that we weren't going to throw away all of these existing projects and start over from scratch. What we really needed to do was figure out some kind of a thin shim layer that we could insert between the two that would mean minor adaptation to the south side of these gray boxes and minor adaptation to the north side of these blue boxes, but fundamentally would allow reuse of all the rest of the work. It took us a really long time to get there, but as of today, I think, we've gotten final approvals and are publishing version 1.0 of an ONF document describing the operating principles for an intent-based system. And so we think we've kind of gotten to the end of high-level design work, and it's time to go start building things and proving that this works and kind of introducing it into the real world. So within the NIC project, we started it up. Everybody was really excited to go. We recognized that the process of building consensus in the ONF was going to take a long time, and we had all these developers really anxious to get going and build something. And so we made a decision to kind of split the two concerns and liberate people to work on the basic use case support and what we'd call the intent engine. And at the same time, we'd work in ONF to try to agree on a common definition, and that at some point we would then come back together and put this new common official northbound interface on top of the existing work. And so that's what we're proposing to do in the very near future. Clearly there's some existing interfaces and support for those interfaces, and we're going to have to work closely with the NIC community and the stakeholders to make sure that when we make this major change on the north side, we do it in a way that's minimally disruptive for everybody. And so this is kind of how we build the intent systems, and one of the things that's interesting to notice here is that we don't have a single instance of an OpenDaylight controller or a single clustered instance where everything sort of shares fate. We're assuming that because this is kind of a branch-oriented topology, it's completely unacceptable to live in a situation where if one of 100 branches goes down, it's going to take down the other 99. And so we're assuming that you really need sort of autonomous controller-level intelligence in each of the branches. And so rather than this being one giant OpenDaylight cluster distributed all over the world, we're going to build a model that looks much more like separate OpenDaylight instances that communicate and share only this intent and mapping data. They don't communicate and share anything else. And we'll talk about that a little more during the presentation. And so, you see an intent engine, basically you split the inputs into this intent stuff and this mapping stuff, and then by talking to the infrastructure directly in a controller-specific way, you're able to sort of put together what was needed with the state of the network and fulfill things. So in order to do that, we're building code in a number of different areas. In the OpenSourceSDN Boulder project, which is an ONF open source project, we're going to build sort of generic intent and mapping logic, so that we're hoping to be able to abstract that in such a way that there's a common piece of Java code that provides most of the functionality and then sort of has a pluggable back end that's pluggable for the platform-based clustering services and persistent services and things like that. And then the other piece that we'll have in that repository is the common intent NBI Yang model. And then in each of the platforms that are going to support this common interface, we end up building kind of specific implementation to plug into that sharing, synchronizing back-end piece. We end up with an NBI that's unique to the platform based on the way the local Yang tools process things. And we assume that within the platforms, that's the opportunity to work off the common interface, but to say I did it better by optimizing something or having faster recovery or better topology discovery. That's the area where we look to see a lot of innovation in the individual controllers. So the way we're looking to build this is essentially today there's the OpenDaylight NIC project. Sort of as we speak, we're in the process of spinning up an ONOS NIC project, and the notion is that in either of those projects, when you start the automated build, The first thing it does is goes to the OSSDN repository and pulls down the latest versions of the Yang files and the latest versions of the Java common code, and then go ahead and build that. And so in this way, the controller agnostic work that we're doing in the ONF gets included and stays consistent and synchronized with the controller specific work that gets done in each of the controller projects. I mean, you really couldn't do this exclusively in OpenDaylight and then say it's a multi-controller, controller agnostic system. You really need kind of a neutral third party to be able to do this credibly, and so the ONF turns out to be a really good place to do that. So, you know, the first thing we're going to do is basically cut off the entire OpenDaylight northbound interface as you know it, encapsulate it underneath a much more abstract interface. So once we build something that you might call sort of an intent-based distribution of OpenDaylight, you won't be able to query the inventory and the topology. You won't be able to push a flow rule into a flow table. All you'll be able to do is tell the controller, here's what I need, and then the controller will figure out whether or not to push rules into tables and you know, all those sorts of things. So initially, the only objects we're going to have are three very simple objects: object group modifier, and one very simple type of mapping entity, which is this 5-tuple object. So the new interface is going to be incredibly simple, and while we're only supporting one use case, that's all there really is to it. We're going to extend the mapping data structures, and we're going to extend the intent objects and modifiers over the next 10 years as we support many, many, many more use cases. And again, this is going to temporarily break everything, and so we're going to work with the community and find a way to give people notice and make it as painless as we can. So at this point, I'm going to turn this over to Iranu, who's doing a lot of the development work on the OpenDaylight side, and let him talk a little bit more about some of the technical details of what we're building, why and how.
So thank you, David. As David said, we should do some changes on the NIC project because this is our current design for the NIC project. Okay. And here we have some couplet code where we are we have a mapping data stored, but we don't have an intent data stored to share the intent and the mapping with other nodes on the cluster. And this is our proposal changes for our design on the NIC project. Once we have the couplet code for the intent listeners and the others handlers, and we can create a common interface to create our intents and our mapping service. And currently we have just a data store for mapping service, but we should create a data store for mapping service and intents. Once we have this, we are applying a new intent, and the first time we can share the intent and the mapping service with all those nodes in a cluster. So this is the next step for the NIC project, where we are creating a data store for those intents and a mapping data store. These two data store will go to will be reachable for all those nodes in a cluster, and we should do we should decode the code on the NIC project, because currently we have some strong integration between the listeners, the component listeners, and the OpenFlow renders, right? So the next step for the NIC will be decode this code and remove the strong dependence that we have on all those models on the NIC project, and share the database for intents and mapping sets. Right, David?
Are you talking about essentially extrapolating what is NIC and the data stores around NIC and intent and the other data into a separate process space from either controller as you go through this thing? Is that kind of the end goal, kind of a intent space microservice?
Yeah, we're still kind of trying to figure out what the right thing to do there is, as we scale out. It seems like logically it's a separate entity that sort of lives above the controller, but the way we're going to have to implement it is to have a little piece of it in each of the controllers kind of cooperating in order to hermetically seal our black box so that people can't get at any of the underlying APIs.
That type of internal stuff, you want to be like all this, you're talking about the classification aspects of that, that'll be the internal controller versus kind of the intent API CLI.
Right.
Right. Once we have once we are creating the intents, the first step should be share the intent and the mapping with all those closures on of the OpenDaylight, right? And instead of create the intent, apply those intent, and then share this with all those nodes, right? This is the point.
To share nothing, so rather than sort of poke it into your local MDSAL and do things with it and then distribute, there's a risk it's already corrupted at that point. We want to sort of distribute just the minimal metadata, then treat it as if each of them are completely autonomous and truly share nothing.
So you have the MDSAL, and then you have the service recipe. The service recipe, I don't know, in ODL is probably a different name. So when the order is entered from the NOC or from a portfolio, that SLA or clause or latency or whatever, is that part of intent or that's separate when you place the order?
So the kind of golden rule of figuring out what is or isn't intent is to say that the intent can't have any implementation specifics in it. So if it refers to an address or a protocol or a vendor feature or any of these kinds of things, by definition it's not part of the intent, it's part of the mapping. But jitter and latency and bandwidth and things like that are absolutely not implementation dependent. They're true intent. They're what you want from the network. So those, what we call sort of modifiers are definitely part of the intent.
So all this interaction that you're showing here, let's stick to ODL for now.
Yeah.
Not ONF,
Of
just
course.
ODL. You have the MDSAL, and then you have the application on the top.
Yeah.
The intent is going to really take the application, whatever the service requirement is, map it into some abstract topology. Yeah? Because you have to have a service topology that you can present that through your NDI to the MDSAL. So instead of now sticking to the existing NDI, which is the ODL, like REST or or whatever, you're defining a new common unified NDI, correct?
Right.
Now, the impact on ODL would be the service or customer interfacing from MDSAL upward. Yeah? Because MDSAL today would only see the NDI, it doesn't see anything else. On the service
Yes. Yes, it's because the intent is an abstraction. The intent doesn't need to know which steps you should be chosen to handle this. The NIC project will we have some resource there, some steps there, and the intent will be just a height abstraction for this. And based on this intent, we can extract which each service we should use to handle this intent, right?
But while you're,
If I can interrupt, let's let him finish because it's a very short session, and then if we have to discuss this offline.
Yes, of course. Yes. Maybe. Sure. Yes, okay. This is our views, and maybe you can talk more details about this.
So
please?
in the short term, we're building sort of a translation agent. Today, Skype for Business has a well-defined, publicly documented interface that exports the kind of information we need to get into the OpenDaylight controller. It hasn't broken it into these, this is the intent and this is the mapping sort of split that we need for the ONF interface. And so the thought is that initially what we're going to do is we're going to build an agent that talks the Skype API unmodified on the north side, talks the intent API unmodified on the bottom side, and sort of translates between the two. Ultimately, we'd like to have the Skype server natively using the intent API, but to get a big company to make changes to a shipping product is a big deal, and we're kind of early in the POC process right now, so the thought is this is an easy workaround, and we don't have to go through the process of getting a high priority change request through the Skype product management team, and then once we've proven that this is a good idea and works well, and we have the Microsoft guys behind us saying this is a good thing, we think we'll probably get the priority we need to get it pushed through.
Yes, of course. It's because of this that we should to do some changes on the NIC project, just to be able to do this. Service.
Someday we'll throw away the agent and just kind of have a native interface, but this is the fastest way to get to sort of demonstration and the initial pilot.
Of course. Any questions so far?
We're officially out of time, but if anybody gets out any questions or finish your question?
Yeah, we can, let me go back.
Of course.
Yeah, of course, these are the details, yeah? We go back to that MD cell. Okay. So, this is going to impact the northbound interface, correct?
Two.
Not
Yes.
the southbound.
Currently, it will impact the southbound for the NIC project because we have a coupled code there. We should remove this coupled code. Once we are removing this, all the intent will be handled by the northbound. You understand? And all the services will be, we can provide all those services in the southbound. Once we have this intent in the northbound, we can translate this intent in the northbound interface and send to the southbound to choose this specified specific service to handle this.
We have to touch every single southbound interface, yeah?
The other we have all the services in the southbound interface. Right. We should provide these services in the southbound.
Maybe we can finish this discussion outside with like the next group. Of
course. Thank you.
All right, we're going to get started. We're running a couple minutes late, but we're going to roll. We're talking about Atrium Enterprise, which is an ODL distribution designed to support, specific, well-defined use cases. We're kind of at work building our first one, and we're going to talk about that. So you've probably seen this slide in some of the other presentations here today, but the basic requirement here from Microsoft IT is to try to reduce their MPLS and sort of carrier-provided WAN costs by having smaller dedicated WAN pipes and offloading things to the internet instead. They talked about sort of the internet first initiative where by default things will go to the internet and only the things that need special treatment will use the expensive corporate network. And so we're building a solution to help them solve that problem in cooperation with some of the ONF members and the Microsoft IT team. So Atrium Enterprise is a distribution of OpenDaylight that's been, tested, integrated, tuned for specific use cases, and sort of recognizing that updated for how to integrate SDN with universal communications. The other thing is to adapt it to the ONF's common intent northbound interface. We've been working in ONF to design a single northbound interface that could be put on all kinds of infrastructure controllers and provide sort of a consistent interface, and I'll talk about that a little more. So that, this is a nice use case because there's just a very simple cost-based ROI. If they can go across all of their many branches across the world and reduce the WAN costs in each of them, it turns out to be pretty substantial. So the why are we doing this SDN thing is really easy to answer. Sort of a midstream project. We have some software artifacts, but the bulk of the thing we build comes from upstream, which is OpenDaylight in this case, and we'll talk about that in a little more detail. So the first use case is this unified communications use case, real-time audio, video, and other kinds of things. There's a specification from the IMTC, which is a standards organization of sort of multimedia, telecommunications, and universal communications providers. And so one of the things we're trying to do is support the specifications they've created. Stream OpenDaylight isn't very consumable for most people, and a lot of people don't want to do super custom things and become deep software developers in order to use it. So the thought is that we'll take the basic distribution, add support for specific use cases, test it with specific pieces of hardware, and certify at some level that this is something that you can take and deploy. And in working with Microsoft as sort of the first partner in this, our goal is to build something that's good enough to meet their needs to the point where they're going to want to deploy it. And in some ways, we're